I will walk you through the steps need to be performed to build effective machine learning model. Then I will take you to STATCRAFT Python, and there we will be exploring various machine learning models like MLP classifier, random forest, SVM classifier, etc. So before moving to today's topics, let's try to recall the content on previous session. So you just tell me uh, what are the types of machine learning. Type in chat box. Just it is for just recalling purpose, so that it will be easy for you to understand today's topic. What are the types of machine learning? Anybody? What are the types of machine learning? Okay, then machine learning is divided into two parts: supervised three parts: supervised machine learning, unsupervised machine learning, and reinforcement learning. Okay, so in last session we have covered about types of machine learning, then how we move to training, testing, cross validation, etc. So let's start with today's session. To get started, I will show you what are the steps involved in building machine learning models. So these are the necessary steps. Without these steps, you will not be able to build effective machine learning model, and you can't trust on your results. Okay, so let's get started. So first step in building any machine learning model is to understanding about the problem. Okay, understanding about the
Amlaka,
problem.
sorry to interrupt you. Can you please share your screen?
Okay, sir. So is it visible, sir? Now, hello.
Yeah, it's visible.
Okay.
Can you just repeat the
Yes, sir.
content? Yes.
Okay. So sorry. So these are the steps involved in building any effective machine learning model. So first we have to understanding our problem. Okay, understanding the problem. So what we need to do then, coming to data collection. Once you understand the problem statement, means whether it is a regression problem or classification problem, you need to understand this first. Then you move on to the data collection part. So you gather the relevant data from public data set, or you collect your data your own or from other databases. Then you check if your problem is if your problem is a supervised machine learning problem, so you need to ensure data should be data should be labeled. Okay, if your problem is supervised machine learning problem, so you need to ensure your data should have labels, proper labeling. Okay, then we move on to EDA, which stand for exploratory data analysis. Exploratory data analysis. So what we do here is we see whether there is some relationship between independent variable and dependent variable. So if we find any relation between them, we try to add that particular feature into our machine learning models. Okay, so what we do, another step here is we visualize our data using histogram, bar plot, overlay bar plots, and try to see if there is any relationship between dependent variable and independent variable. So it help you to identify the features which will be important in building your machine learning model. So once you understand this one, you try you go for data pre-processing. Okay, data pre-processing. And what you do here is, because StatCraft Python only deal with numerical data set. If your data set contain categorical variables and it has labels like, so let's say your data set contain gender and it has two labels, right? Male, female. And if you try to build machine learning model with this categorical variable, so since Python does not work with categorical data, you need to record this particular categorical variable into numbers. Let's say we will record it female with 0 and male with 1. So this kinds of thing you have to do in data pre-processing. And also what you can do here is you try to identify whether my features contain any missing values, duplicate values, uh, whether it contain outliers. Okay, then next step is feature engineering. Here we try to build, means since we have already features in our data set, but we try to define our new features, like we will see on our data set. There we will be doing feature engineering. Next, splitting your data. So in last session, StartCraft Python session, we have discussed about training and testing. So once you if you build machine learning model, so how you are going to test the effectiveness or quality of your machine learning model. So for that, what we do is we divide our whole data into training and testing. So after dividing data into training and testing, we build our model, we train our machine learning algorithm on training data set. And after building the machine learning model, after feeding machine learning model, you can test the quality of that machine learning model using testing data set. Okay, and at last you can choosing the right model, choosing right model for your ML task. Okay, uh, right model in the sense which give you the accuracy matrices higher, means effective accuracy matrices. Like we have some accuracy matrices which help you to understand the quality of your machine learning model. So here we have some accuracy matrices like precision, recall, f1 score. So we will see that in more detail. So now let's uh, jump into StatCraft Python. So how many of you have access today to laptops? Hello, can you just comment in chat box? If you have access to PC or desktop, I will explain you how you can log into StatCraft Python. so that it will be a bit hands-on session. Please reply in chat box. How many of you access to PC? So let me explain you how you can log into STATCRAFT Python. So to log in, all you have to do is just open the any Chrome browser on your device, then enter URL learn.python.startcraft.in. Okay, then hit enter your username, password, and that's it. You are login to StartCraft Python. So this is how StartCraft Python interface looks like. Just a minute. So so to see our data set, if you can go to this source, and here you will find the dataset previously imported to your login credential. So because StatCraft Python provides email with password policy, this has become essential repository to all of your dataset. So you can come back years later, you can switch between devices, all of your dataset will be here into your unique login credentials. So this is the dataset we are going to working on today. Let's click on this. So this is basically the Titanic survival dataset, which contain information like passenger ID, their class, their name, gender, age, a number of siblings, number of parents, their tickets, fare, cabin, and where they embark. I mean, basically these are the places name. I think they have given in a short form. So these are the places where they embark on the ship. And here we have our target variable name, survive or not, where 0 represent they are not survive and 1 represent they survived. Okay, let me go to meta tab. There we will check the data type of all the variables. So our survive has a categorical variable because it is categorical in nature, and the passenger ID. So coming to our data set, now you can see here we have some variables, passenger ID, name, and then this cabin. I don't think so these variables are going to add any value to your machine learning models. So what we will do is we will delete these variables right away. So to do that, just click on this view tab, then go to source and click on the meta tab of the particular data set. Just click on meta tab, and here you can see we have passenger ID, their cabin, and this variable name age. Okay, sorry, name. So what I can do is I can delete this, then their name, and I will delete this cabin. Okay, so if you come back to the data set, here you can see we have successfully deleted that unnecessary variables because they are not going to add any value to our machine learning model. So now we have what we have to do is since I already explained you Python only deal with numerical data set, but our data set contains some features which have categorical values like, sorry, text values like male, female, and this embark also contained categorical variables. So I think we need to record this value first to build machine learning model. So what we can do is first we try to see if there any relationship, if these variables have any relationship with our dependent variable or not. Then if there is some relationship, we will record these variables. Okay. So let me give the labels to this dependent variable. Okay. So now here we have variable name gender and variable name survive, where 0 represent they are not survive and 1 represent they are survive. So let's say I want to visualize the relationship between this gender and whether they are survive or not. So what we have to do is just click on this hamburger menu at the top left corner, then go to graphics. Okay, then click on this count plot, give variable name. So here you can see we have list of all the variables contained in our data set. So here you can give the bar analysis title. So survived overlay with gender. Okay, and what is a variable of our interest? It is survived, and we are going to overlay it with gender. Okay, also you can customize your count plot, and I want the vertical orientation, so I am going to change it to vertical. Okay, here also here you can select the axis title, axis labels for x-axis and y-axis. I will take it as a frequency, then click on OK. So this is the result we are getting, R code and tabulated results. Okay, so on the x-axis we have survive category, where 0 present they are not survive and 1 represent they are survive. So you can see here we can see here clear pattern is there. Okay, so in this not survive category, you can see most of the male passengers are not survive. So you can say there is a 90-10 pattern, means 90% of the male contain not survive. Okay, so coming to survive category, here you can see in survive category around approximately 80% of the female passengers are survive. So this will be the very important variable while we build machine learning model. Okay, so let's note down this variable here, gender. Okay, coming to our data set again. Now here we have variable name fair. Okay, now I want to check if there is any difference between, if there is any difference between this fair in a survive category and not survive category. For that what we can do is we can plot this fair overlay with survive. So to do that, just click on this analysis tab, then go to graphics. Just a minute. Or you can use box plot. Okay, so and I will do it here as a group, and you can see here we got the list of all the variables contained in our data set. So what is our x variable? It is fair, and we will, it is fair. Okay, and we will overlay it with survived. Okay, and so it will give us a box plot for these two categories of survive, 0 and 1. Just a minute. I think in this case bar plot will be, sorry, histogram will be effective. So what we can do is we can take variable as fair and overlay it with survive category. Okay, then click on OK. So this is the result we are getting. R code and tabulated result. So you can see here the people who are not survive has very uh, low fare tickets. You can see here most of the people who are not survive having very low fare tickets. But when you come to the survive people, they have you can see here these people have high fare tickets. Okay, so this can also be the good feature to build our machine learning model. So let note down here this as well. Okay, let's come back to our data set. Now you can see here. I think we have deleted our important variable called cabin. So let me import the data set again. So to import, just click on this source, then click on this. I will delete this current data set. Click on plus icon. By mistake I deleted that cabin variable. Then click on upload table and let select the dataset you want to. Once you click on dataset, you will show all the variables contained in your dataset. Okay, then click on OK. So since I don't want this feature, so I will delete this feature right away. Go to source and go to the meta section of that particular variable. Delete this passenger ID, their name, and ticket. Okay, coming to our data set. So now you can see here here we have variable name cabin, and you can see here this variable contain lot of missing values. Generally what we do is if some of the feature contain lot of missing values, we delete such a type of variable. So but here we are going to follow some different approach. What we can do is if cabin is not present, I will record this variable with 0, and if cabin present, I will record it 1. Okay, so to do this, all you have to do is just click on this analysis tab, then go to data, click on prepare, and click on derive. Okay, now click on this condition, and I will take this cabin. If cabin is null, okay, then click on validate. Okay, cabin is null, replace it with 0, otherwise make it 1. So 1 means they are assigned with cabin. Need take new variable cabin and click on OK. So now we can see here we have created a new variable which contain two values, 0 when 0 and 1, where 1 0 represent they are not assigned with cabin, and 1 represent they are assigned with cabin. So I don't want this cabin variable. I don't want now. So go to meta tab and I can delete this. Okay, so we are left with 10 features here, not 10, 9 features and one dependent variable. Okay, so now what we can do is let's say I want to see whether there is some association between this survive category and cabin new category, where in a survive 0 represent they are not survive and 1 represent they are survive. Okay, so go to this hamburger menu, click on this hamburger menu, then click on graphics, then click on count plot. Okay, so already we have y variable is survive. Now this time I will replace this gender with cabin new. Okay, and click on ok. So this is the result we are getting. So these bars for not survive category and these bars for survive category, where this bar represents they are assigned with cabin and these bar represent they are not assigned with the cabin. So you can see there is some kind of association between these variables. So in this not assigned category, in not survive category, most of the people around 70% of the people are not assigned with cabin. Here you can see, you can map this with this. So you can see in this bar, in these bars you can see most of the passengers are not survive with, so are not assigned with cabin. But when you come to this survive category, there is some kind of 60-40 pattern. Okay, so in this case, if the passengers are assigned with the cabin, they are more likely to survive. So this one observation we can make here. Okay, so we will write down this one as well. Okay, so what is this one? Cabin. So these are the variables are affecting our output variable, sorry, dependent variable. Okay, now coming to our data set again, now we are left with this variable embark variable, and also we can check if there is association between this variable and survive category. Okay, so follow the same steps, go to analysis tab, graphics, then click on count plot. Okay, and then what you have to do is just replace this cabin new with embark, click on ok. So this is the result we are getting, code and this one, color rich and colorful graph. So this is the survive category and this is not survive category. When you come to survive category, so you can see the people who are embarked at this station S station are very likely to not survived. Okay, most of the people, most of the passengers who are embarked on this S are not survived, followed with this C and followed with this one Q station. Okay, but while you come to this survived category, you can see here there is no huge difference between bars. You can see in this category there is a huge difference between size of these bars and these bars. Here you can see some kind of 40-60 pattern. So which means the passengers who are embarked at this C station or Q station are more likely to survive than this one S. Okay, so you can note this one also to build machine learning model. But what you can do is, if these independent variable also have any interrelationship between them, to check that you can go to graphics and go to count plot. Okay, so and this time I replace this survive with gender. coming to this plot. Okay, so these bars are for male and these are for female for each category. Okay, so you can see here in a male category, most of the people are embark on the station S. Okay, and followed with this one C and followed with Q. So you can see here there was association between survive category and where they embark. But if you can see also there is also interrelationship between gender and where they embark. So if you add your independent variable which having strong relationship between them into machine learning model, so it will arise multi-collinearity problem. So we are going to add only one variable and that one is cabin. Okay, so this is about, now we have note down uh, gender is affecting our dependent variable, fare is also affecting a dependent variable, and cabin is also affecting dependent variable. And also we have seen embark embark is also affecting our dependent variable. And what is that one? Survived. But what other thing we have observed here is there is an interrelationship between gender and embark. So if we add these two variables into model to predict whether they are survive or not, it will arise multi-collinearity problem. So we are going to add either of these two features. So I will avoid this embark feature into our machine learning model. Okay, so now let's try to build some machine learning model. So before doing that, since this gender variable is categorical in nature, we have to record this into numerical feature. How you can do that? Just go to analysis tab, go to data, prepare, then click on record. Okay, now let's select the gender and I will give name as gender new. Okay, and I will replace female with 0 and male with 1. Then click on OK. So now we can see here we have created our new variable name gender new. Okay, and since we don't want this embark variable, I can delete it right away. Okay, so this is the case, and you can see here we have two variables, number of siblings and number of parent children. So if you think carefully, if we add these two variables, we can generate new variable from that. So if you add these two variable, we can generate new variable from this. So to do that, just click on analysis tab, click on data, prepare, click on derive. Okay, and make it to formula. And what we can do is we can add this number of siblings plus number of parents. Click on validate. Again, click on OK. Give variable name. So since we are adding number of siblings and number of parent children, we can give name like family size. Okay, then click on OK. So now you can see here we have created our new variable name family size, which we have created by adding number of siblings and number of parent children. Okay, so now I think now we are ready to build our machine learning model. So to build machine learning model, all you have to do is just click on this hamburger menu at the top left corner, then click on machine learning, and let's try with MLP classifier. Okay, so here is the list of all the variables sorry, contain in our data set. So what is our dependent variable here? Our dependent variable is survive. So to add this variable in dependent variable, you have to take it as a categorical variable. Okay, our dependent variable should be categorical in nature. To do that, click on this source, click on meta, and this is the survive. So it should be numeric and its measure should be categorical. Okay, then only our machine learning model will take it. Then click on this analysis tab, machine learning, click on MLP classifier. Okay, select give analysis title, though it is optional. Select the dependent variable as a survived, and select independent variable as age, siblings. Sorry, don't add siblings, because since we have created our new variable called family size, and also since these variables are in numeric, so we have to convert them into numeric. Okay, if you have any doubts in between, you can ask me any point of time during session. Okay, go to analysis tab, click on machine learning, then click on MLP classifier, add our dependent variable which is survived. Hello, hello. Okay, so let's add age, fair, cabin new, gender new, and family size. Okay, then go to parameters. Here we have various parameters. So here is the sizes of number of hidden layers, number of iteration you want for your machine learning model. So you can see by default we are taking 90% of the, sorry, 75% of the data set for training. I will make it as a 70. Okay, so for this particular model, I am taking 70% of the data set for training and 30% for the testing. Okay, then you can select the seed here, go to options. So here you can see here we have various activation function like ReLU, identify, logistics, TANH. Similarly, we have solvers like LFBGS, Adam, SGD, and whether you want early stopping or not, you can select it from here, and you can go to save. If you click on save, here you can see three options to save model, predicted values. If you want predictive values and probabilities, you can click on here, then click on OK. So this is the result. We are getting Python code and this tabulated result. So you can see here we got our confusion matrix for training and for testing as well. So basically, just a minute. So now here we have confusion matrix, but I think you don't know what is confusion matrix. So let's try to explore that part as well. So to understand this one, we will log into STATCRAFT LMS, then select the username. Then click on this introduction to Python using STATCRAFT P. Then click on machine learning and click on model evaluation. Okay, then click on slides. So the this is how the confusion matrix looks like. So this side we have actual negative and positive classes. So these are the actual, means it contained in our data set, and these are the predicted model by our machine learning model. So what is confusion matrix? It is the contingency table which shows number of am I audible? Hello? 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 Am I
Yeah.
audible?
Yes, sir.
Okay. So what is confusion matrix here? Confusion matrix is a contingency table which shows number of correctly and incorrectly classified classes corresponding to each class. So you can see here we have negative and positive classes. So basically these are the positive and these are positive. If actual are positive and predicted by our model is also positive, then this is the correct decision, right? And what we call it is true positive. If actual is positive but our model is saying negative, so this is the incorrect prediction, right? If our model is if actuals are negative and our model is saying positive, then this is also incorrect classification. And if our model is saying negative and sorry, actually is negative and our model is also saying negative, then this is the correct decision, right? So these diagonals are the incorrect classification. Okay. And what are the false positive? False positive is a type 1 error and false negative is a type 2 error. Okay. So confusion matrix comprises of four elements: true positive, false negative, and true negative. Means if our actual is positive and model is also saying positive, then this is the true positive. Okay. If model is saying our actual is negative, model is also saying negative, then this is true negative. Okay. And these are other two types. So let's understand these terms here. Here FP means our model is wrongly predicted positive class. Okay. So identifying normal as a spam call. So for example, you can take example of spam call. Identifying normal call as a spam call. FN means our model is incorrectly predicted negative class. Identifying spam as a normal call. Then TN means our model correctly predicting negative classes, identifying normal class as a normal class. Okay. Then here we consider spam as a positive. Okay. And not spam or normal call as a negative. So here we have certain accuracy matrices, sorry, model evaluation matrices. Into that list, first we have accuracy. Okay, sir. So first here we have accuracy matrices. So how you find accuracy? It is find out correctly, like it is find out correctly classified data values. So it can be obtained by using the formula. So what is the formula for that? Accuracy is equal to TP, means true positive plus true negative. Okay, divided by all predictions. Coming to our confusion matrix. So how you find true positive plus true negative divided by sum of all these predictions. So this is how we find accuracy. Okay. So this is how we find accuracy. Next accuracy, sorry, model evaluation matrices is a precision. It can be used to identify how model correctly classified the positive class. Okay. Out of the total predicted positive class. So what portion of class is actually positive class? It can be calculated by using the following formula. Precision is equal to TP upon TP plus FP. So where typically TP means true positive. Here in the denominator we have true positive plus false positive. Okay. Next we have recall, or you can call it sensitivity or true positive rate. It is used to find out the proportion of positive prediction out of total observed positive class. It can be calculated by using following formula. So if recall is equal to 2 positive divided by 2 positive plus false negative. Okay. Then we have specificity. How it can you can calculate is it can be used to find the proportion of negative prediction out of total observed actual negative class. It can be calculated using following formula. And at last we have F1 score. So it is the harmonic mean of precision and recall, and it can be obtained by using the following formula. So what is F1 score? It is 2 into recall into proportion divided by recall plus precision. So identifying the good accuracy matrices or uh, model evaluation matrices is a very crucial step in machine learning model. So because since you can build, anybody can build any machine learning model, but you have to check whether my model is of good quality or not. So these accuracy matrices or these model evaluation matrices are going to help you to understand whether your model is good fit or not. Okay. So just a minute. So let me ask you some questions. Why we divide our data into training and testing? Why we divide our data into training and testing? Anybody? You can write in chat box. Why we divide our data into training and testing? So as I explained, we divide our data into training and testing, 70% for the training and 30% for the testing. So why we divide our data? What is need? Why do we need to split data into two parts? Anybody? 14 people, 12 people are watching. Anybody? Why we divide our data into training and testing? Anybody? Why we divide our data set into training and testing? Okay, I think nobody knows. So why we divide our data set into training and testing is because once you build your machine learning model, anybody can build any machine learning model. But if you have to check, you have to ensure your model is of good quality or not. So for that purpose, we train our model into on 70% of the data set, and we use remaining 30% of the data set for testing purpose to check whether it is good fitted or not. Okay. So here we have precision and accuracy, precision, and recall. Okay. So when to use which precision, which when to use which model evaluation matrices. So you can use accuracy as your model evaluation matrices, when your data set is balanced. Data set is balanced in the sense means there are approximately equal number of two labels. Okay, let's understand this with example. So let's say now in our dataset content survived. Survive has two categories, 0 and 1 means 1 represent they are not 0 represent they are not survived. Okay, and 1 represent survived. So when you should use accuracy as a model evaluation matrices when these two labels are number of this label should be equal in a number means if our data set contain thousand observation, so 500 should be survive approximately, not exactly equal, or 500 should be not survive. Okay, so this is how the balance data set should look like, or you can say 500, 600, but it should not like 100 are survived and 900 not survived. So it is highly imbalanced data set. So in this case, if you are going to use accuracy as a accuracy as a model evaluation matrices, so it will not tell you whole story. So let's say out of 900 not survived. Okay, out of 900 your model what is formula for our accuracy? True positive upon true positive plus false positive, right? Let me erase this part. Okay, so accuracy is equal to true positive upon for true positive plus FV, which is basically false positive. So true positive means actual label is positive and your model is also saying it is positive, and false positive means actual label is negative but your model is saying positive. Okay, so let's say 90 of the labels are for not survived and 100 are survived. Okay, so this is the highly imbalanced data set. Now if you say our model has predicted 900 out of 900 as a correct true positive. Okay, so in this case true positive means your actual level is positive and your model is also saying positive. So let's say your model have identified all the positive cases. Okay, but it is not able to identify the negative class which is hundreds in number. So if you calculate this one it will come around 900 divided by 1000. Okay, okay, so now what you are getting here is 0.9, so you are getting 90% accuracy. So in this case you are saying my model is very good at predicting the classes, but you can see here it have not identified this 100 classes. Okay, so in this case if your data set contain highly imbalanced data set, so in this case your accuracy is will not be the good model evaluation matrices. Okay, so coming to false, this is the precision. When should you use precision? When false positive is very expensive in nature. Okay, false positive is very expensive in nature. And when should you use recall? When false negative is very expensive in nature, right? Means let's say you take an example of the patient have disease. Let's understand this one. Okay, so this is our positive class. In practical, which class has very means rare number of labels, we call it as a positive, because this is our class of interest. Because obviously if our data set contain this negative class more number, so obviously it is going to capture this one. So but our goal is we have to capture this rare class. Okay, so let's say some very rare diseases there, and we have to identify whether that patient has that rare disease or not. So in that case, this class will have rare means few labels. Very few observation have this disease label, and most of the, like you can say 70-30 pattern there. So most of the observation have, yes, correct Gunjan. So if most of the patient don't have cancer, right? As Gunjan said, most of the patient don't have uh, cancer. So in that case, obviously our model will capture that category, means they do not have cancer. Okay, so obviously since many people don't have this disease, so our model is going to capture this easily, but our goal is to find the people who have that disease. So this is where so if our model is capturing this category, then our model is considered as a good fitted model, right? Just a minute. So what is precision here? Okay, so what is formula for precision is true positive upon false positive upon, sorry, true positive upon false positive. So basically false positive is saying the patient don't have cancer, but our model is saying it has cancer. So you can say here it is not that expensive in this case. Means if our model is saying this particular patient have cancer, so this is not that means it is also bad thing. But if our model is saying that person has cancer, then we can go further and again analyze with the doctor whether actually it has a cancel or not this person. But when you type, when you say recall, so what will be the recall here? True positive upon true positive plus false negative. Okay, but if you consider this one, true positive on true positive plus false negative, so what is false negative here is means model is saying actually this patient don't have cancer, but our model is saying it has cancer. So this is very expensive case here. Sorry, I made mistake. This particular patient has a cancer, but model is saying it don't have a cancer. So this will be very expensive case here in this particular example. So in such a scenario, you should use recall as your model evaluation matrices, not precision and not accuracy. Okay. So it is basically depend on what is more expensive here. So you can see here, if model is saying this particular patient have a disease but it actually don't have, so that is not very expensive. But if model is saying actually the patient have disease but model is saying it don't have, so it is very expensive thing. So these are the examples help us to understand which accuracy matrices we should use in a particular case. Okay. So coming to our STATCRAFT Python, so you can see here we got our confusion matrix. So these are the misclassified classes. These are for training and these are for testing. We are particularly interested in testing, right? So let now you can answer me, what should be our sorry, model evaluation matrix here in this particular example. So here our dependent variable is survive, where 0 represent they are not survived and 1 represent they are survived. Okay. So you can see here we got our recall value as 0.84, but this is for training. If you see this for recall, if you see this for testing, you can see here we are getting recall of 0.83 and recall for this one category as a 0.69. So it is not that good because model is considered as a good fitted if it has accuracy matrices over 80%, 80% or 85% according to the nature of your problem. So I think MLP classifier is not performing that well on this particular case. Let's try with another model. So click on machine learning model. Now this time we will try this a random forest classifier. Okay. Now what is our dependent variable? It is survived. Click on age, siblings, not siblings, because we have created another feature using these siblings and parent children. Click on cabin new, gender new, and family size. Go to parameters, then select the number of trees you want to build. You can set a minimum sample to split as a 10. Okay, then you can set the seed as a 42, and I will take 70% of the data set for training and 30% for testing. So let's come down here. So here you got feature importance here. So what is most important feature here is in predicting whether they are survive or not. You can see gender new is the most important feature for predicting whether they will survive or not, followed with fair, age, family size, and cabin new. Okay. Coming to confusion matrix. So this is the confusion matrix for training, for testing. So now we can see in this time we have increases, we are getting recall as a higher. I think last time it was 0.68, and by now you can see we got our recall as a 0.78. So bit it is improved this time. Okay, let's try to do some modifications here in parameters or features to random forest classifier. So this time let's drop this family size. Click on OK. So now you can see we are getting recall as a 0.82. Okay. So you can consider this as a good machine learning model. Just a minute. Feature importance, and you can see here this gender new is most important variable here for predicting survive or not. So that's all from my side. Now if you have any questions, doubts, you can ask me. If you have any doubts, do let me know in chat box. Actually, just a minute. It is the chat.
Kamlakar, there is one query. Accuracy 85 plus would
Yes,
be
yes, sir.
considered.
Sir, actually, I am not able to see that one, sir. Sir, can you name that particular who is asking that one?
Gunjan Shukla.
Okay, Gunjan. So as I explained, you have to understand the nature of your problem. Means if your data set is highly imbalanced, so in that case, accuracy should not be very good accuracy matrices. So you have to consider what is more expensive, whether the false positive is more expensive or whether the false negative is more expensive. So this is how you select your model evaluation matrices. If the data set is balanced, so 80% accuracy can be considered as a good accuracy. But again, this is also depend on the nature of your problem, because if you are dealing with medical problems, so in that case uh, you should achieve 90% accuracy, above the 90%. Okay, it depends on how your problem is, nature of your problem. Uh, Did I answer well, or means I should I explain more? Any other questions? Now it is clear, Gunjan, right? Okay. You have any other questions? And similarly, you can try other models as well. So here you have seen we have seen here MLP and random forest. So similarly, here we have various models: MLP, regressor, decision tree classifier. You can try that at own. Sir, I think there are no further questions, so we can end the session here.
Yes, we can end the section.
Okay.
Thank you for joining in with us. Then I request participants to use the software by logging into learnpython.statcraft.in. So we'll end the section over here, Kamla then. Yes.
Yes, sir. Sure.
Thank you.
Thank you all for listening.